In the infinite silence of space, our planet glows like a faint blue spark, fragile, solitary, and alive. For centuries, humankind has gazed upward, asking the same haunting question. Are we alone? Every culture, from the ancient Greeks to modern astronomers, has tried to answer it. Yet after all the telescopes, probes, and equations, the universe has remained frustratingly silent. Life, it seems, may be a rare and delicate accident, an anomaly adrift in the dark. But what if that's not true? In recent decades, science has begun to whisper a different story, one of hidden oceans, frozen moons, and worlds where chemistry itself seems poised to breathe. The boundaries of the possible have shifted. Once we thought our solar system was barren. Now we are learning that it might be full of places where life could exist. It began with a revolution not of belief but of data. In 2009, NASA launched a small telescope called Kepler. Its mission was simple: stare at a single patch of sky and measure the tiniest flickers of starlight. Yet from those faint dimmings, Kepler revealed something extraordinary, that planets are everywhere. Billions of them, more worlds than stars. That discovery rewrote astronomy overnight. If every star is likely to host a family of planets, and if even a fraction of them resemble Earth, then the universe may be teeming with potential homes for life. Suddenly, the question wasn't if other worlds exist, it was which ones could live. Meanwhile, within our own solar system, a quiet drama was unfolding. Robotic explorers, tiny emissaries of metal and code, began to peel back the icy layers of nearby moons and planets. On Mars, ancient riverbeds whispered of lost seas. Around Jupiter, the moon Europa shimmered with a crust of ice hiding an ocean beneath. Saturn's moon Enceladus erupted jets of water vapor into space, carrying hints of organic molecules. And far beyond, Titan, shrouded in golden haze, revealed lakes of liquid methane under an alien sky. Each of these discoveries chipped away at our old certainties. Life, we realized, might not need Earth's gentle climate or sunlight to begin. Could thrive in darkness under pressure within chemical chaos. Perhaps it already has. And so, for the first time in human history, the search for life beyond Earth is no longer a question of fantasy. It is a scientific investigation, one that spans continents, decades, and billions of kilometers. From observatories on mountaintops to orbiters circling Mars, from rovers digging through dust to telescopes staring across galaxies, we are probing the boundaries of biology itself. But with every discovery, the mystery deepens. For all our instruments and missions, not one piece of direct evidence, not a single cell, fossil, or whisper of alien DNA has yet been found. The silence continues, and that silence has weight. Still, scientists persist, because the implications are too vast to ignore. If life began here on a single small world around an average star, then perhaps it could begin anywhere. And if even one other spark exists out there, then we are not the universe's only story. This investigation is no longer just about microbes or oceans beneath the ice. It's about identity, about what it means to be alive in a cosmic ocean of possibilities. The search for life is the search for connection, for understanding whether biology is a universal phenomenon or an impossible miracle. Tonight, as telescopes scan the skies and probes glide through alien shadows, a new chapter in that search is being written. We will journey from the red deserts of Mars to the frozen moons of Jupiter and Saturn, to the exoplanets orbiting distant suns, each step guided by the same relentless question that has haunted us since the dawn of thought. Is life an amazing phenomenon exclusive to our planet, or is it the rule of the cosmos itself? Perhaps, somewhere out there, on a world bathed in another star's light, someone or something is asking the same question. And perhaps soon we will both have an answer. Part 1. The First Signs. When Mars whispered back, for as long as humans have looked toward the night sky, Mars has been the mirror of our imagination. It's close enough to see with the naked eye, a red ember wandering through the stars, and yet distant enough to hold our deepest hopes and fears. Ancient civilizations named it after gods of war. Modern astronomers called it the Red Planet. But underneath those myths lies something far older. The intuition that Mars might once have been alive. That suspicion began centuries ago. In the 19th century, early telescopes revealed faint dark streaks and lighter planes across its surface. Some astronomers, most famously the Italian Giovanni Schiaparelli, thought they saw canals. Straight, unnatural lines stretching across the planet's face. Soon, science and fiction collided. Newspapers declared that intelligent Martians were building irrigation systems. Authors like H.G. Wells and Percival Lowell turned these blurry lines into maps of a dying civilization struggling to survive. The canals, of course, turned out to be an illusion, artifacts of imperfect optics and eager minds. But the question never faded. Could Mars still harbor life, perhaps hidden beneath its dusty skin? The 20th century would begin to answer. When the Mariner 4 probe flew past Mars in July 1965, the truth it revealed was sobering. Its photographs, grainy, black and white, showed a world of craters and desolation. No canals, no cities, just an ancient, frozen wasteland. For a generation, that image defined Mars, the dead planet. But science is restless. It refuses to accept endings too easily. In the decades that followed, each new mission peeled away another layer of mystery. The Viking landers in 1976 performed the first experiments searching directly for microbial life. Their instruments scooped Martian soil, mixed it with nutrients, and waited for signs of metabolism. A faint breath of gas, a chemical reaction, any whisper of biology. For a moment, the data seemed promising. One of the 3 life detection experiments registered an unexpected chemical response, almost as if something in the soil was alive. Yet when the other tests returned negative results, optimism collapsed into controversy. NASA concluded there was no evidence of life. Others disagreed, claiming the Viking mission might have destroyed what it was trying to detect by exposing delicate microbes to harsh chemical reagents. For decades, the debate smoldered quietly. Then, in 1996, it reignited with a rock. In the icy deserts of Antarctica, scientists recovered a meteorite labeled ALH 84001, a fragment ejected from Mars millions of years ago that had drifted through space before falling to Earth. Under the microscope, it revealed strange microscopic structures, tiny oval shapes, shockingly similar to fossilized bacteria. The announcement shook the world. President Bill Clinton stood before cameras in the White House and said, "If this discovery is confirmed, it will be one of the most stunning insights into our universe that science has ever uncovered." But confirmation never came. Other researchers soon argued that the formations could be purely geological, shaped by chemical reactions, not biology. Once again, the hope for Martian life dissolved into uncertainty. Yet each mission that followed added a piece to the puzzle. In 2008, NASA's Phoenix lander touched down near the Martian North Pole and scraped beneath the crimson dust. There, it found what no one had ever seen before: bright white patches that vanished after a few days. It was ice, water ice just beneath the surface. Orbiters soon confirmed it wasn't just at the poles. Vast underground reserves of frozen water stretched across the planet. Mars, it turned out, wasn't entirely dry. And where there's water, there's possibility. In 2015, the Mars Reconnaissance Orbiter delivered another surprise. Its instruments detected dark, narrow streaks flowing down steep Martian slopes during the warmer months, then fading as the planet cooled. The spectrometer readings revealed hydrated salts, evidence that these streaks were made of briny liquid water. Liquid, on Mars. It was one of the most extraordinary discoveries in planetary science. The image of Mars began to change again. No longer a dead rock, but a world in between life and silence. A place where frozen seas might still melt in sunlight, where microbial colonies could lie dormant under layers of dust, waiting for warmth to return. Today, we know Mars once had rivers, lakes, even oceans. Billions of years ago, its atmosphere was thicker, its sky perhaps blue, its valleys filled with water. Then something changed. The magnetic field faded. The solar wind stripped its atmosphere away. The oceans boiled into space, leaving behind a desert of rust and rock. But deep underground, life might have found refuge. On Earth, microbes known as extremophiles survive in boiling volcanic vents, inside Antarctic ice, even miles beneath the ocean floor, feeding on minerals, radiation, or the chemistry of rocks themselves. If such life thrives here, why not there? Every rover sent since has been chasing that question. The Curiosity rover, launched in 2011, found sedimentary rocks shaped by ancient water and traces of organic molecules, the carbon-based building blocks of life. The Perseverance rover, which landed in 2021, is now gathering samples for the first-ever planned return to Earth. Somewhere in those tiny cores of Martian soil, scientists hope to find chemical fingerprints, isotopes, organics, or microfossils that could finally prove whether Mars was once alive. Even now, as you read this, Perseverance stands silent beneath the orange sky, its instruments humming. Somewhere below its wheels, a billion years of history lie buried, waiting. If life ever began on Mars, it would mean the spark of biology ignited twice in one solar system. Two origins, two stories. And if life could emerge on both Earth and Mars, then the universe might not just allow life, it might favor it. For now, Mars remains a question mark written in dust and time. But it has already taught us one vital truth. The universe is not empty. It's active, dynamic, and capable of more than we ever dared to imagine. In the distance, other worlds are calling, places where the clues grow stranger and the possibilities even greater. Next, we turn to the frozen moons beyond the asteroid belt, where beneath miles of ice, vast hidden oceans whisper through the dark. Part 2. Beneath the ice. Europa's silent ocean Jupiter dominates the solar system like a restless god. A planet so vast it could swallow more than 1,000 Earths. Around it whirl dozens of moons, each one a small world of its own. But among them, one stands apart. Europa, a bright, glacial sphere that glows like a pearl in the cold light of the sun. At first glance, Europa seems unremarkable. It's slightly smaller than Earth's moon, and from space, it appears smooth and pale, etched with long cracks that crisscross its surface like frozen scars. Yet that deceptive simplicity hides one of the most extraordinary secrets in the solar system. An ocean vast, deep, and alive with mystery, lying beneath miles of ice. We know this because of a spacecraft named Galileo. In the 1990s, NASA's Galileo mission orbited Jupiter for nearly 8 years, passing Europa a dozen times. Its images changed everything we thought we knew about frozen worlds. Unlike other moons, Europa's surface had few craters, meaning it was young, constantly renewing itself. Some regions looked as though giant slabs of ice had broken apart and drifted, before freezing again in new positions, just like ice flows on Earth's polar seas. The patterns were unmistakable. The crust was moving, floating on something liquid below. Then Galileo measured a faint magnetic field surrounding Europa, an anomaly that could only be explained by a salty, conductive ocean hidden under the crust. Suddenly, the idea of an alien sea became more than speculation. Scientists began to imagine what such an ocean might look like. A global sea, 100 kilometers deep, sealed beneath 20 kilometers of solid ice. More than twice the volume of all of Earth's oceans combined. A world in perpetual darkness, lit only by the faint glow of chemical reactions at its depths. But for water to remain liquid in that cold, some form of heat must exist. And Europa has plenty. As it orbits Jupiter, Europa is locked in a gravitational tug-of-war. The gas giant's immense pull flexes and squeezes the moon, generating frictional heat within its interior. It's the same process that powers volcanoes on Jupiter's other moon, Io, but on Europa, the heat melts ice instead of rock. This tidal heating could drive hydrothermal vents on the seafloor, just as they do in Earth's deep oceans, vents that spew mineral-rich water into darkness, creating oases of warmth and chemistry. On Earth, such vents teem with life. Bacteria, tube worms, crabs, and creatures that thrive without sunlight, drawing energy from the planet itself. If similar vents exist on Europa, then life there might not only be possible, it could be inevitable. In 2012, the Hubble Space Telescope detected faint plumes of water vapor erupting from Europa's south pole. Geysers shooting hundreds of kilometers into space, similar to those on Saturn's moon Enceladus. These jets suggest that the ocean below is active, interacting with the surface. If confirmed, it means that we might one day sample Europa's ocean without even landing by simply flying through its vapor. Such discoveries transformed Europa from a cold curiosity into a priority target. NASA scientists began to speak of it with a kind of quiet reverence, the place, perhaps, where we are most likely to find alien life in our own backyard. Still, caution remained. Water is only one piece of the puzzle. Life also needs the right chemistry, carbon, nitrogen, and energy sources. Could these ingredients exist so far from the sun? Evidence suggests they could. Galileo detected carbon dioxide on Europa's surface, likely produced by radiation striking organic compounds below. Other instruments hinted at sulfuric minerals, salts, and complex molecules mixed in with the ice. Together, these findings painted a portrait of a world chemically rich and dynamically alive. And then came another clue, one that made scientists pause. In 2013, researchers analyzing Galileo's data found traces of clay-like materials, phyllosilicates, on Europa's surface. These minerals form only when rock and water interact over long periods, exactly the kind of environment where prebiotic chemistry, the first steps toward life, might begin. If Europa's seafloor is rocky, volcanic, and bathed in water, it could mirror the conditions where life began on Earth billions of years ago. The parallels are almost eerie. It's no wonder then that both NASA and the European Space Agency have placed Europa at the center of their next great missions. NASA's upcoming Europa Clipper, set to launch in the 2030s, will orbit Jupiter and perform nearly 50 close flybys of Europa. It will scan the moon's surface with radar to measure the thickness of its ice shell, analyze the plumes for organic molecules, and map its composition in unprecedented detail. Meanwhile, ESA's JUICE mission, short for Jupiter Icy Moons Explorer, launched in 2023 and will reach the Jovian system by 2031. It will study Europa along with Ganymede and Callisto to understand the potential for life in these frozen worlds. Together, these missions mark the beginning of a new era, one where habitability is no longer confined to planets bathed in sunlight, but extended to moons of ice, warmth, and darkness. Yet even with all this technology, Europa remains an enigma. We still don't know what its ocean looks like, whether it's a sterile abyss of water and salt, or a cradle of alien life evolving unseen for eons. To imagine that, scientists look again to Earth. Beneath the Antarctic ice, deep under kilometers of frozen layers, lie hidden lakes untouched by sunlight for millions of years. When explorers drilled into these icy tombs, they found microbes alive, metabolizing, waiting, life that had endured in total isolation. If Earth's biosphere can thrive in such conditions, why not Europa's? It's a humbling thought that somewhere beneath those pale, fractured plains, an ecosystem may be stirring, ancient, silent, and utterly alien. Perhaps there are organisms that feed on chemical gradients, colonies that rise and fall with the tides of a world that has never seen the sky. And if a probe ever pierced that ice, if we ever glimpsed something swimming in that distant sea, it would change everything. The discovery of life on Europa, even a single microbe, would mean life is not a cosmic accident. It would mean biology is as natural as gravity, a property of the universe itself. For now, Europa keeps its secrets. Its ocean whispers under the crust. Its geysers vanish into the void. But humanity is coming with radar, spectrometers, and dreams. And beyond Jupiter's orbit, another icy world is waiting, one that might already be giving away its mysteries in plumes of salt and steam. Part 3. The Geysers of Enceladus. A moon that breathes far beyond the orbit of Jupiter, Saturn drifts in silent majesty, a ring giant surrounded by more than 60 moons. Most of them are barren chunks of ice and rock, ancient relics circling in the planet's faint light. But one of them, small, gleaming, and seemingly unremarkable, has transformed from an astronomical footnote into one of the most intriguing places in the solar system. Its name is Enceladus. At just over 500 kilometers across, Enceladus could fit comfortably inside the borders of France. Yet what this tiny moon lacks in size, it makes up for in secrets. In 2005, NASA's Cassini spacecraft, sent to explore Saturn and its moons, flew close to Enceladus and saw something no one expected. Out of the moon's south pole, vast plumes of water vapor were erupting into space, shooting hundreds of kilometers high. They shimmered in sunlight like silver smoke, stretching outward into Saturn's rings. Cassini's cameras captured the spectacle. Enceladus was venting ice and gas into the void. The discovery stunned the scientific community. How could a world so small, so cold, produce such power? The surface temperature was a brutal -200 degrees Celsius. By all logic, Enceladus should have been frozen solid, a dead rock drifting in darkness. Yet beneath its icy crust, something was alive with motion and heat. Cassini's instruments quickly revealed more. As the probe passed through the plumes, its sensors tasted the vapor, detecting water, salts, and, most remarkably, organic molecules. The same basic ingredients of life as we know it: carbon, hydrogen, nitrogen, oxygen. The plumes, scientists realized, weren't just frozen geysers. They were vents, openings that connected the surface to an ocean below. An ocean, a sea of liquid water beneath an ice crust, hundreds of kilometers deep, warmed by energy from within. The heat, much like on Europa, came from tidal forces. As Enceladus orbits Saturn, the planet's immense gravity stretches and flexes the moon, generating internal friction. That friction produces heat, melting parts of the icy mantle and keeping the ocean liquid. The tiger stripes, massive fissures crisscrossing Enceladus's south pole, are the points where that subsurface ocean bursts through. Cassini's data painted a vivid picture. Beneath the cracked ice lay a global ocean touching a rocky core. And where rock meets water, chemistry thrives. Scientists began to connect the dots. On Earth, hydrothermal vents, deep-sea fissures where hot water rich in minerals gushes from the crust, are home to ecosystems that thrive without sunlight. Here, in total darkness, bacteria convert chemical energy into life. Whole communities of organisms feed on that invisible power. If similar vents exist on Enceladus's seafloor, could life have evolved there too? In 2015, Cassini delivered a crucial clue. Its spectrometer detected tiny silica particles in the plumes, particles that could only form in hot, alkaline water interacting with rock at temperatures near 90 degrees Celsius. In other words, hydrothermal activity. Enceladus wasn't just geologically active, it was chemically alive. Dr. Hunter Waite, a lead scientist on Cassini's ion and neutral mass spectrometer team, said it best. Enceladus is the first place beyond Earth where we found all three of the key ingredients for life: liquid water, chemistry, and an energy source. That realization turned Enceladus from a curiosity into a beacon. For years, researchers had dreamed of finding another habitable environment in the solar system. They expected it to be Mars or perhaps Europa. Few imagined it would come from a moon so small it barely held onto its own gravity. And yet, there it was, venting proof of its potential into open space. Cassini dove through the plumes 14 times before its mission ended. Each pass revealed more detail. The jets were made of 90% water vapor, mixed with methane, carbon dioxide, ammonia, and complex organic compounds. Some even contained molecular hydrogen, a potential energy source for microbes. On Earth, similar hydrogen-rich vents host thriving microbial colonies, sustained purely by chemistry. If Enceladus's ocean mirrors those conditions, it could sustain life, primitive, microscopic, but unmistakably alive. The challenge now is proof. Cassini was never designed to detect living organisms, only to study chemistry. It flew through the plumes at thousands of kilometers per hour, collecting fleeting traces of particles and vapor. The evidence it found was tantalizing, but not conclusive. To know for sure, we need to return with a mission built for biology. And that's exactly what scientists are planning. 2 proposed missions, NASA's Enceladus Orbalander and the Life Investigation for Enceladus Life Project, would explore the moon in unprecedented detail. One would orbit Enceladus, sampling its plumes repeatedly. The other would attempt to land near the South Pole, where the geysers erupt. The idea is simple but revolutionary. Capture fresh particles from the plumes and analyze them for signs of metabolism, amino acids, or even cellular structures. It would be the first direct search for life beyond Earth since Viking touched down on Mars nearly half a century ago. But there's something poetic about Enceladus. Unlike Mars, it doesn't hide its secrets underground. It shares them, ejecting pieces of itself into space, as if inviting us to investigate. It breathes. It exhales the ingredients of life into the void, each plume a message carried on frozen air. Standing on its surface, if one could withstand the cold, would be an otherworldly experience. The horizon would glow faintly from Saturn's reflected light, the sky dominated by the planet's golden rings. Beneath your feet, the ground would tremble as geysers roar, sending shimmering arcs of ice into orbit. It would be the most alien landscape ever seen, and yet, paradoxically, perhaps the most Earth-like in its potential. Enceladus forces us to confront a staggering idea, that life might not be unique, not even rare. It could emerge wherever water and energy meet, even in the frozen corners of our solar system. If future missions find even a single living cell in those plumes, it would mean biology is not a cosmic accident, it's a universal process. And it would mean that we, the living, are not the exception but the expectation. For now, Enceladus remains silent, its geysers whispering into the vacuum. Cassini ended its mission in 2017, diving into Saturn's atmosphere to avoid contaminating the very worlds it helped make sacred. Yet its discoveries linger blueprints for the next great search. And as scientists turn their eyes outward, another moon waits in Saturn's orbit, larger, thicker, and even stranger. A world with seas and rain, but not of water. A world called Titan, where rivers of methane flow beneath orange skies, and chemistry itself begins to dream. Part 4, Titan. The methane seas of a primordial world. If Europa is a frozen mirror of Earth's oceans, and Enceladus a hidden vent of life's chemistry, then Titan is something altogether stranger. A paradox wrapped in haze. It's the largest moon of Saturn, bigger than Mercury, and for decades it was nothing but a blurry orange in our telescopes. No light escaped its dense atmosphere. No surface could be seen. To the naked eye, Titan was a mystery. That veil began to lift in 2004, when NASA and the European Space Agency's Cassini-Huygens mission reached Saturn after a 7-year journey through deep space. As Cassini began orbiting the planet, it released a small probe, Huygens, designed to dive into Titan's atmosphere and land on its surface. No one knew what it would find. What happened next changed our understanding of what a habitable world could be. As Huygens descended through the thick orange clouds, it transmitted images every few seconds. At first, only swirling haze. Then, astonishingly, shapes began to emerge. Dark branching lines that looked eerily familiar. River channels, valleys, floodplains. When the probe touched down, it sent one final image before its batteries died. A view across a plain scattered with rounded pebbles. They looked like river rocks, smoothed by running water. But they weren't rock at all. They were ice, frozen so hard by Titan's minus 180 degrees Celsius temperatures that it behaved like stone. And the water that had carved those channels? It wasn't water at all. It was liquid methane. Titan, it turned out, had rivers, lakes, and seas, but of methane and ethane instead of H2O. It was the only other world in the solar system with stable liquids on its surface. Beneath its golden clouds, Titan possessed something that no other moon had: weather. Cassini's radar revealed vast, dark regions near Titan's poles, the first seas ever found beyond Earth. The largest, Kraken Mare, is nearly the size of the Caspian Sea. In Titan's dim twilight, methane rain falls from hydrocarbon clouds, carving valleys, filling lakes, and evaporating again, a complete cycle just like the water cycle on Earth, but made of alien chemistry. To stand on Titan would be to stand in a dream, a landscape at once familiar and utterly foreign. The gravity is low, the air thick, you could flap your arms and almost fly. Above you, a permanent orange haze would hide the stars. And across the horizon, black seas of liquid methane would lap against icy shores, silent and endless. Scientists began to realize that Titan might not just be strange. It might be important. Its thick nitrogen-rich atmosphere and abundance of organic molecules made it a natural laboratory for the kind of chemistry that could precede life. In Titan's upper atmosphere, sunlight and cosmic rays split methane and nitrogen, triggering complex reactions that form hydrocarbon chains and polymer-like molecules called tholins, reddish-brown substances that fall like dust onto the surface. Tholins are fascinating. On Earth, they can serve as the raw material for amino acids and nucleotides, the building blocks of life. Titan, in a sense, is performing prebiotic chemistry on a planetary scale, a living reenactment of what early Earth might have looked like 4 billion years ago. But could such chemistry lead to life? That question divides scientists. The temperatures on Titan are unimaginably cold, far below the freezing point of water. Chemical reactions that occur in seconds on Earth would take millennia there. Life as we know it, based on liquid water, would be frozen solid. Yet some researchers propose that life on Titan might not be, as we know it, could be methane-based, a form of biology that uses hydrocarbons instead of water as a solvent. In 2015, a team at Cornell University modeled such an organism, suggesting that membranes made from small nitrogen-carbon compounds could remain stable in liquid methane. They called them azotosomes, theoretical cell-like structures that might float in Titan's seas, metabolizing with methane chemistry instead of oxygen. If that's true, Titan might host a form of life completely unrelated to Earth, a second Genesis with a different chemical language. The implications are staggering. All known life shares a common origin, a single biochemical blueprint. But if Titan's lakes harbor even primitive methane-based cells, it would mean life doesn't just adapt to new environments. It invents new chemistries. It would mean the universe isn't biased toward carbon-water life. It's creative, varied, and universal in its drive to evolve. For now, we have hints but no confirmation. Cassini orbited Saturn for 13 years, passing Titan more than 120 times. Each flyby revealed more about its bizarre weather, its sand dunes of organic dust, its ever-changing clouds. But no spacecraft has yet landed again since Huygens. That may soon change. NASA has approved a bold new mission, Dragonfly. Set for launch in 2028, Dragonfly is not a rover. It's a nuclear-powered drone. When it arrives at Titan in the mid-2030s, it will fly across the surface, hopping from site to site like a robotic explorer in slow motion. Its target is Shangri-La, a vast dune field near the equator, rich in organic material. From there, Dragonfly will travel to the crater Selk, where ancient impacts may have melted ice, creating temporary pools of liquid water, a perfect environment for complex chemistry. The mission's goal is ambitious: to analyze Titan's surface for signs of prebiotic molecules, and perhaps, if fate allows, for signs of life itself. Dr. Elizabeth Turtle, the principal investigator of Dragonfly, once said, "Titan is both an analog to early Earth and a laboratory for chemistry that could represent life's other possibilities. If Dragonfly succeeds, we may witness something unprecedented. Not the discovery of alien life, but of alien potential." Titan challenges us to think beyond the narrow boundaries of biology. On Earth, life arose from water and sunlight, but Titan shows us another path, one written in methane and haze, a chemistry frozen in time, perhaps waiting for a warmer future to awaken it. In the grand hierarchy of worlds, Titan may be a kind of cosmic memory, a portrait of Earth before life began. Or it may be something else entirely, a living world we simply haven't learned how to recognize yet. As Cassini's final images of Titan faded to black in 2017, the probe plunged into Saturn's atmosphere and burned, its last radio signals whispering across 1 billion kilometers before falling silent. But Titan remains, turning slowly beneath its eternal clouds, a frozen ocean of possibilities. And while the outer moons hold their secrets in ice and methane, the universe beyond Saturn stretches endlessly outward, a field of stars, each one a potential sun. In the next chapter of our journey, we'll leave the solar system behind. We'll cross the vast interstellar gulf to worlds orbiting other stars, planets we cannot yet touch, but whose shadows whisper that we are not alone. Part 5, The New Frontier. The Kepler revolution. For centuries, humankind imagined that our solar system was unique, a lone family of planets orbiting a single star in an otherwise empty universe. Every ancient model of the cosmos, from Aristotle to Copernicus, placed our world at the center of something special. Even after we learned that the sun was just one star among billions, a quiet assumption lingered. Perhaps its planets were the exception. Then, in 1995, that illusion shattered. Astronomers Michel Mayor and Didier Queloz, observing from the Haute Provence Observatory in France, announced the discovery of 51 Pegasi b, a giant planet orbiting a star much like our sun, just 50 light-years away. It wasn't the kind of planet anyone expected. It was massive, hot, and clung to its star in a blistering 4-day orbit. A hot Jupiter, impossible by traditional theory, and yet there it was. For the first time in history, we had proof that other stars had planets. The era of the exoplanet had begun. Over the next decade, new detection techniques, measuring the tiny wobbles of starlight or the faint dips in brightness as a planet crossed in front of its star, began to reveal worlds by the dozens, then hundreds. Gas giants, rocky dwarfs, even planets orbiting pulsars, dead stars that pulsed like cosmic lighthouses. The universe, it turned out, was not shy in its creativity. But the true revolution came in 2009, when NASA launched a telescope named Kepler. Unlike earlier missions, Kepler didn't study individual stars. Instead, it stared at a single patch of sky, a seemingly quiet field in the constellation of Cygnus, and watched more than 150,000 stars at once. Its task was simple and audacious: detect the minute dimming that occurs when a planet passes in front of its star. For 4 years, Kepler measured light with relentless precision, billions of tiny fluctuations, each one a potential signal from another world. The results were astonishing. Within months, Kepler had confirmed hundreds of planets. Within years, it had identified thousands. By the end of its primary mission, scientists realized the truth. Planets were not rare at all. They were everywhere. Nearly every star in the galaxy seemed to host at least one. Some had entire families of worlds, mini solar systems orbiting suns of every color and size. Suddenly, the Milky Way transformed from a lonely expanse into a teeming cosmic archipelago. Dr. Natalie Batalha, one of Kepler's lead scientists, described it this way: "Before Kepler, we thought planets were the exception. After Kepler, we realized they are the rule. But among all these worlds, one question towered above the rest: which of them could support life?" To answer that, astronomers looked for planets in the habitable zone, the region around a star where temperatures allow liquid water to exist. Not too hot, not too cold, the Goldilocks zone. Kepler began to find them, small, rocky planets orbiting quietly within those golden distances. One of the first was Kepler 22b, discovered in 2011. About twice the size of Earth, orbiting a sun-like star 600 light-years away, it was the first confirmed planet in the habitable zone. Its discovery ignited a spark. Maybe Earth wasn't alone. Then came Kepler 62e and Kepler 62f, a pair of planets circling an orange dwarf star in the constellation Lyra. Both worlds were likely covered by deep oceans, shrouded in humid skies. Though they lay 1,200 light-years away, They seemed hauntingly familiar, blue, temperate, alive with potential. But the most famous discovery came in 2014, Kepler 186f. Roughly the same size as Earth, Kepler 186f orbits a red dwarf star about 490 light-years from us. It receives just one-third the light Earth does, placing it near the outer edge of its star's habitable zone. Yet the physics fit perfectly. Its size suggested a rocky surface. Its orbit implied a stable, gentle climate. For the first time, astronomers could point to a planet and say, this one might truly resemble Earth. It's a milestone, said Elisa Quintana, a scientist on the Kepler team. This is the first Earth-sized planet in the habitable zone of another star. It's a step closer to finding a world that could host life. The discovery of Kepler 186f electrified the scientific community. Artists rendered it as a crimson Earth, its sky tinted orange by the light of a cooler sun, its surface etched with clouds and oceans. It became the symbol of a new era, the era of Earth 2.0. And then, just a year later, came another shock, Kepler 452b. Orbiting a G-type star almost identical to our Sun, Kepler 452b sits in nearly the same position Earth does, a cosmic twin 1,400 light-years away. It's about 60% larger, perhaps with thick clouds and deep oceans. Its star is older and slightly brighter, meaning the planet may be entering a greenhouse phase, a glimpse, perhaps, of Earth's far future. Dr. John Jenkins, who led the discovery team, called it Earth's older, bigger cousin. It wasn't just a poetic line. For the first time, we had found a planet orbiting a star so similar to the Sun, at nearly the same distance, that it felt less like another world and more like a mirror. In a single decade, Kepler had rewritten the story of our place in the cosmos. Where once we knew of 9 planets, now there were thousands. Where once Earth stood alone, now it was one among billions of possibilities. But Kepler's mission was more than just a catalog of orbits and numbers. It was the beginning of a new kind of astronomy, one that blended data with imagination, physics with philosophy. Each discovery forced us to ask not just what's out there, but who might be looking back. As Kepler's fuel dwindled and its gyroscopes failed, the telescope was finally retired in 2018. It drifted silently through space, its sensors dark, its gaze frozen forever on that same patch of sky. Yet its legacy was eternal. It proved that the universe is not an empty stage, but a crowded theater, and we are only one act in a play that spans 100 billion worlds. And just as Kepler fell silent, new eyes were already turning toward the stars. The James Webb Space Telescope, with its golden mirrors, promised to go beyond detection, to see exoplanet atmospheres directly, to search for chemical signatures of life. Oxygen, methane, water vapor, biomarkers. For the first time, humanity had the tools not just to imagine other Earths, but to analyze them, to peer into their skies and perhaps read the faint chemical traces of biology. Somewhere in that vast sea of data, amid the flickering light of a distant sun, might lie the first real evidence that we are not alone. But even as we look outward, the story turns inward again. Because if life can emerge on planets around other stars, then what about the strange, extreme environments right here in our solar system, worlds we once dismissed as uninhabitable? Our search is not just about distance anymore. It's about understanding the boundaries of life itself. The next discoveries would challenge those boundaries even further, leading to an even stranger system, orbiting one of the smallest stars in the galaxy, where 7 Earth-sized planets circle in an impossible dance, a system called TRAPPIST-1. Part 6, TRAPPIST-1. 7 worlds around a dying sun in the quiet darkness of the constellation Aquarius, 40 light-years from Earth. A faint red star burns with a fragile glow. It is small, barely larger than Jupiter, and so dim that no human eye can see it without a telescope. For most of history, it went unnoticed, just another ember in the galactic sea. Its name is TRAPPIST-1, and around it circles one of the most extraordinary planetary systems ever discovered, 7 Earth-sized worlds, dancing in perfect resonance. The discovery began, fittingly, in a place that itself gazes into darkness, an observatory in Chile's Atacama Desert. There, amid the driest air on Earth, astronomers used the TRAPPIST telescope, named after the Belgian beer brewed by monks, to monitor faint, red stars for tiny fluctuations in brightness. In 2015, one such fluctuation caught their attention. The star dimmed slightly, then brightened again. Then, days later, it dimmed once more. Not once, but several times, with patterns that could only mean one thing: multiple planets passing in front of their sun. By the time NASA's Spitzer Space Telescope joined the observation campaign in 2017, the full picture emerged. 7 rocky planets, each roughly the size of Earth, all packed within a space smaller than Mercury's orbit around our sun. 7 worlds. It was unlike anything ever seen before. The TRAPPIST-1 system is a cosmic clockwork, a gravitational ballet so precise that each planet's orbit resonates with the next. Planet B circles the star in 1.5 days, C in 2.4, D in 4, and so on, a mathematical harmony that allows scientists to predict their positions with perfect accuracy. But what captured the world's imagination wasn't just the number of planets. It was what they might be made of. All 7 appeared to be rocky, not gaseous, true terrestrial worlds. And at least 3 of them, TRAPPIST-1e, F, and G, lay squarely within the habitable zone, where temperatures could allow liquid water to exist. For the first time, humanity had found an entire family of potentially habitable worlds, all orbiting a single nearby star. Dr. Michael Gillen, the Belgian astronomer who led the discovery, said in awe, "We didn't just find one Earth-like planet. We found a system full of them." To astronomers, it was like stumbling upon a miniature version of the solar system, compact, delicate, and brimming with promise. But TRAPPIST-1 star is no gentle sun. It's an ultra-cool red dwarf, only about 0.08 times the mass of the sun. Such stars burn dimly but live for trillions of years, cosmic survivors that outlast galaxies. Yet they are also volatile, capable of flaring violently and bathing their planets in bursts of radiation. That raised a critical question. Could life survive under such conditions? Red dwarfs are strange. Their habitable zones lie so close to the star that planets there are likely tidally locked, with one side in perpetual daylight and the other in endless night. On TRAPPIST-1e, for example, the day side might roast under the faint red sun, while the night side freezes in shadow. Yet between them, along the terminator line, the thin boundary of twilight, conditions could be just right. Warm winds could circulate heat, keeping oceans from freezing and creating climates stable enough for life. It's an eerie vision, a world where the sun never rises nor sets, where one hemisphere bakes while the other slumbers beneath an eternal sky of stars. And in that twilight belt, clouds might drift above alien seas, illuminated by the dull red glow of their dying sun. To find out what these planets are really like, astronomers turn to the James Webb Space Telescope, JWST. With its massive gold mirrors and infrared eyes, JWST was built to peer into precisely such systems, to dissect their light and read the chemical fingerprints of their atmospheres. Within months of its 2022 launch, Webb aimed its gaze at TRAPPIST-1. The results came slowly, but they were historic. The telescope detected subtle differences in light as planets passed in front of the star, minute signals that hinted at the presence or absence of atmospheres. Early results suggested that TRAPPIST-1b and C may have lost much of theirs to stellar radiation. But TRAPPIST-1e, the 4th planet, seemed different, denser, cooler, and perhaps still wrapped in a thin veil of gases. It was, in many ways, the best candidate yet for habitability beyond our solar system. To understand its scale, imagine this. If you could stand on the surface of TRAPPIST-1e, your sky would be crowded with worlds. Other planets would appear as bright crescents, some larger than our moon, each one a neighboring Earth suspended in the dark. You could see their continents, their clouds, their oceans, all orbiting the same dim red star. For planetary scientists, the TRAPPIST-1 system is a living laboratory, a place to study how worlds evolve together, how gravity shapes them, and whether life might arise in environments utterly unlike our own. But it also forces us to ask deeper questions. If life exists in this system, would it spread from one planet to another, carried by meteorites and debris? Could a biological signature, a spore, a microbe, survive an interplanetary journey in such close quarters? On Earth, we call this idea panspermia, the seeding of life between worlds. If panspermia operates in TRAPPIST-1, then perhaps all 7 planets share a common biological ancestry, 7 variations of one genesis. And if it happened there, why not here? Some scientists now suspect that Earth itself may be part of such a cosmic lineage, that life could have come to us, not from divine accident, but as a visitor from beyond. The TRAPPIST-1 system, in its quiet orbit, is more than an astronomical curiosity. It is a test case for the universality of life, a natural experiment conducted by the cosmos. The data continues to flow in. Webb will keep studying the planet's atmospheres, searching for the chemical hallmarks of life, oxygen, methane, carbon dioxide, existing in delicate balance. On Earth, that mix can exist only when living organisms constantly renew it. If we detect such disequilibrium there, it would be our first strong sign that something is breathing under another sun. TRAPPIST-1 is not bright, but its significance burns hotter than any flame. It reminds us that life's story may be written not in isolation, but in chorus, 7 worlds singing the same note, echoing across space and time. And as we listen, another realization dawns. If red dwarfs, the most common stars in the galaxy, can host habitable planets, then the universe might be far richer in life than we ever imagined. Perhaps half the stars you see tonight have worlds like these. Perhaps countless civilizations orbit in red light, evolving slowly beneath dim suns. As we watch them from our pale blue world, we are witnessing the first flickers of a new cosmic perspective, one that says life is not an anomaly, but a pattern. And yet, the more we find, the more we are forced to ask. If life is so common, where is everyone? That question, first posed by Enrico Fermi in 1950, remains the most haunting mystery of all. Part 7. The Fermi Paradox. The silence between the stars by the time the TRAPPIST-1 system was discovered. Our galaxy had revealed itself as a cosmic metropolis, billions of stars, billions of planets, endless possibilities. Statistically, life should be everywhere. The numbers almost insist on it. And yet, when we truly listen, the universe is silent. No radio signals, no alien beacons, no unmistakable artifacts orbiting distant suns. Just static. This silence is what physicists call the Fermi Paradox, the contradiction between the high probability of extraterrestrial civilizations and the complete absence of evidence for them. It began with a simple question. In the summer of 1950, the Italian physicist Enrico Fermi was having lunch with colleagues at Los Alamos National Laboratory. The conversation drifted to UFOs and the possibility of other civilizations. Fermi, always the pragmatist, asked just 4 words that would echo through decades of science and philosophy. Where is everybody? The room fell quiet. It was a fair question. The galaxy is more than 13 billion years old, long enough for civilizations, even at sublight speeds, to colonize every star system many times over. If intelligent life is common, then shouldn't the sky be filled with their presence? But it isn't. That unsettling silence has become one of the deepest mysteries in science, not just about astronomy, but about existence itself. To explain it, thinkers have proposed dozens of hypotheses, each more haunting, more profound than the last. Some believe we are simply early, that intelligent life takes time, and humanity happens to be among the first sparks to awaken. In this view, the cosmos is still in its dawn. Life's chorus has yet to begin. Others suspect we are late, the remnants of a once-living galaxy now gone quiet, after civilizations rose, burned bright, and fell into oblivion. But one idea stands above all in its eerie simplicity: the Great Filter. It suggests that somewhere along the evolutionary path, from chemistry to intelligence, from technology to interstellar travel, there is a bottleneck so narrow that almost no species passes through. A cosmic barrier. The filter could lie behind us. Perhaps life itself is so improbable that Earth is the rare exception. Or it could lie ahead, meaning that most civilizations destroy themselves before reaching the stars. Nuclear war, environmental collapse, artificial intelligence, uncontrolled biotechnology, the methods vary, but the outcome is the same: silence. If the great filter lies ahead of us, then every barren world we find is a grave marker, a warning written in dust. Still, there are other possibilities, less grim but equally mysterious. Maybe advanced civilizations exist, but they choose not to broadcast, practicing what some call the dark forest hypothesis. In a dark forest, every creature must stay silent, for fear of predators. In the vastness of the cosmos, shouting your presence could be fatal. Perhaps the galaxy is teeming with life, but all are hiding, listening, watching. Or perhaps communication itself is impossible. The scales of time and distance are so vast that even if signals are sent, they may arrive millions of years too late, long after the sender and receiver have vanished. Civilizations may bloom and die like sparks in the night, never overlapping in time. Another theory suggests we may be looking in the wrong way, expecting life to resemble us. We search for radio waves and oxygen atmospheres, but what if advanced life uses technologies or chemistries beyond our comprehension? What if their communication is written not in light or sound, but in quantum states, neutrino pulses, or the very structure of spacetime? To them, we might be invisible. To us, they might be incomprehensible. Yet amid this philosophical vastness, one fact remains unshaken: the search continues. Since the 1960s, the search for extraterrestrial intelligence, SETI, has swept the skies with radio telescopes, listening for narrowband signals, the kind no natural process can produce. In 1977, the WOW signal briefly electrified the scientific community, a powerful, unexplained burst of radio energy from the constellation Sagittarius, lasting just 72 seconds. It was never repeated. Decades of listening since have yielded only the same quiet hum of space. But silence, scientists argue, is still data. Each frequency ruled out narrows the possibilities, sharpening our understanding of where and how to listen next. The new generation of telescopes, like Meerkat in South Africa and the upcoming square-kilometer array, will survey billions of stars with sensitivity orders of magnitude greater than before. If a single civilization is transmitting within 1,000 light-years, we might finally hear it. And if we don't, that absence will speak volumes. It could mean that we truly are alone, a singular experiment in consciousness adrift among the stars. If so, it would make life not just precious, but almost sacred. Or it could mean that we've been looking for the wrong thing, that the evidence of life is already all around us, written not in radio waves but in patterns we have yet to decode. Some theorists even suggest that advanced civilizations might transcend physical existence entirely, uploading their consciousness into digital matrices, becoming beings of information. They would no longer need planets or stars, and their presence would be nearly undetectable. Such ideas stretch the limits of both science and imagination, but they all orbit the same central truth. The silence is not an answer, it's an invitation. The Fermi Paradox forces us to confront the fragility of our own existence. If the great filter lies ahead, then our greatest duty as a species is to survive it, to learn, adapt, and reach beyond it. Because if life is truly rare, then we carry not just our own story, but the story of the universe itself. The night sky, once filled with mystery, becomes both humbling and heavy. Each star a possibility, each silence a question. Somewhere, perhaps, a civilization once looked outward, as we do now, wondering if it was alone. And maybe, just maybe, their signals are already on the way, racing through the void, destined to arrive long after we are gone. The paradox is not merely scientific. It is existential. It reminds us that the search for others is also the search for ourselves, a mirror held up to our fears, our hopes, and our destiny. But if the silence between the stars feels absolute, there are still whispers, fleeting, strange anomalies that defy easy explanation. In 1977, it was the WOW signal, In the 2000s, it was mysterious repeating radio bursts from deep space, the so-called fast radio bursts, short, intense pulses of energy lasting only milliseconds. Most are natural, but a few behave too oddly to dismiss entirely. And in 2015, one star, KIC 8462852, nicknamed Tabby Star, began flickering in ways no one could explain. Its light dimmed by up to 22% irregularly, unpredictably, too much for planets or dust. Some speculated wildly, perhaps an alien megastructure, a Dyson sphere harvesting starlight. The idea was soon dismissed, replaced by more mundane explanations. But for a moment, the world remembered how it felt to wonder again. Because in the end, that's what the Fermi Paradox really gives us. Not despair, but wonder. A reminder that, in the silence, we are still listening. And perhaps, beyond that silence, something is listening too. Part 8. The Signals. When the universe spoke back, silence, no matter how absolute, can never fully extinguish curiosity. After all, humanity's greatest discoveries have always begun in the quiet. A flicker in the noise, a question without an answer. By the early 21st century, the search for extraterrestrial intelligence had evolved into something almost mythic. Generations of scientists had spent their lives listening, recording, analyzing, and yet all they had to show for it were stars that whispered nothing back. But that changed when the silence itself began to stutter. Started, as these things often do, with a signal. A small team of astronomers at the Parkes Radio Telescope in Australia had been monitoring bursts of energy in 2007 when they detected something extraordinary. A millisecond pulse so bright it saturated their instruments. It came from somewhere far beyond the Milky Way, a single, sharp flash of radio energy unlike anything seen before. They called it an FRB, a fast radio burst. At first, scientists assumed it was a glitch, a terrestrial interference, perhaps from a passing satellite or microwave oven. But as more bursts were discovered, the truth became undeniable. These were cosmic. They came from billions of light-years away, each releasing more energy in a millisecond than the sun does in days. What caused them? No one knew. Some pointed to colliding neutron stars, others to magnetars, dense magnetic remnants of dead suns. But a few, whispering against the grain of convention, dared to ask another question. Could these bursts be artificial? The speculation was outrageous, and yet the timing patterns of some FRBs were too precise to dismiss easily. One burst, in 2016, appeared to repeat every 16.35 days, an almost metronomic rhythm. Another, catalogued in 2020, pulsed in pairs, like a binary heartbeat. Natural or not, FRBs reignited the imagination of a species desperate to know it wasn't alone. But then came something stranger still. In 2021, researchers using the Breakthrough Listen program, the most ambitious SETI initiative in history, funded by Yuri Milner and endorsed by Stephen Hawking, picked up a narrowband radio signal coming from the direction of Proxima Centauri, the star nearest to the Sun. The signal, dubbed BLC-1, lasted for several hours and appeared in the same frequency range that SETI scientists had long considered ideal for interstellar communication, between 982 and 983 MHz, known as the water hole, where cosmic background noise is lowest. It was steady, unmodulated, and remarkably clean. For weeks, astronomers debated its meaning. Could it be interference from Earth? A reflection from a satellite? Or had we finally caught a whisper from another civilization, perhaps one orbiting Proxima b, the temperate exoplanet discovered just a few years earlier? For months, the world watched in quiet awe as data poured in. But in the end, the mystery resolved itself the way most do, mundanely. The signal was traced to human-made electronics, probably a distant, drifting source on Earth. Still, for a brief moment, the universe had seemed to hum with potential. Dr. Sophia Sheikh, one of the lead analysts, later said, "It was the first signal in years that made us stop and think, this could actually be it. And perhaps that's what mattered most. Because even if the signal wasn't alien, the search itself was. It was an act of faith in science, in curiosity, in the idea that across the darkness, someone else might be listening too." As data improved, the cosmic landscape of possibilities grew stranger still. New telescopes began to capture technosignatures, patterns of light or heat that might suggest advanced technology. In 2015, one star, KIC 846-2852, better known as Tabby's star, began to flicker in ways that defied explanation. Its brightness dropped by as much as 22%, not periodically like a planet's transit, but irregularly, chaotically, as if something vast and uneven were orbiting it. Dust? Comets? A debris cloud? Every natural explanation seemed to strain under the data. And so, inevitably, came the more radical hypothesis: what if it was artificial? What if some immense alien structure, perhaps a Dyson sphere, a megastructure designed to harvest stellar energy, was blocking the light? The idea was sensational, irresistible. For months, headlines buzzed with speculation. Have we found an alien civilization? Further studies eventually identified more mundane causes, likely a combination of fine dust and fragments from disintegrating exocomets. The mystery faded, replaced by data and logic. Yet even among the scientists who debunked it, the wonder lingered, because for a fleeting moment the cosmos had felt alive. Dr. Jason Wright, who first proposed the Dyson sphere hypothesis, later reflected, "It probably wasn't aliens, but the fact that we could even ask the question, that we have the technology and imagination to test it, is a triumph of our species." And he was right. Every time we look deeper, we find new mysteries, not because the universe hides from us, but because it refuses to be simple. The search for extraterrestrial intelligence is no longer a fringe endeavor. It has become one of the most interdisciplinary fields in science, merging astronomy, chemistry, biology, data analytics, and philosophy. With every radio sweep and every spectroscopic reading, humanity refines its question. What counts as life? What counts as intelligence? What counts as a signal? The James Webb Space Telescope and upcoming observatories like LUVOIR and HABEX are now turning those questions into experiments. Instead of listening for deliberate broadcasts, they are reading atmospheres, scanning exoplanets for combinations of gases that shouldn't coexist naturally. Oxygen and methane, for instance, quickly destroy each other unless something, like biology, continually replenishes them. Detecting that balance would be like overhearing a conversation in chemical code, the whisper of metabolism on another world. And beyond the technical instruments, a new movement is forming: SETI 2.0, a philosophy of the search that no longer assumes communication must be intentional. It looks for the side effects of civilization: heat signatures from megastructures, reflected light from city-scale engineering, even patterns in pulsar timing that might reveal artificial manipulation. The universe, it turns out, may already be full of signals, we just haven't yet learned how to read them. But the pursuit itself has changed us. We no longer gaze into the void as passive observers. We are participants, small, sentient fragments of a universe trying to understand itself. Each telescope, each algorithm, each silent night of listening is an act of cosmic introspection. If intelligent life exists out there, it's possible they too began as we did, looking upward, searching, wondering if they were alone. The great irony is that across the infinite distances, both sides might be waiting for the other to speak first. So perhaps the silence isn't emptiness at all. Perhaps it's the brief pause before the echo returns. And when it does, when the first unmistakable signal arrives, everything will change. Because that signal, when it comes, will not merely confirm we are not alone. It will redefine what it means to be alive. And yet, some scientists believe that the signal has already come, not in radio waves, but in mathematics, in physics, in the quiet fingerprints of order that appear where chaos should reign. They argue that the universe itself may be the message. That the laws of nature, symmetry, constants, the improbably fine-tuned balance that allows matter to exist, are the signatures of a deeper intelligence woven into the fabric of reality. If that's true, then we've been surrounded by the signal all along, and we simply mistook it for silence. Part 9. The hidden pattern. Is the universe itself alive? When scientists speak of life, they usually mean something small: cells, DNA, metabolism. But what if that definition is far too narrow? What if life is not just something that exists within the universe, but something the universe itself does? It sounds poetic, even mystical. And yet, more and more, physics and cosmology are forcing us to reconsider the boundary between matter and mind, between biology and the cosmos itself. At first glance, the universe appears mechanical, governed by equations, constants, and immutable laws. But beneath those laws lies an uncanny precision. The balance of forces that allow stars to form, atoms to exist, and chemistry to unfold is so exact, so fine-tuned, that even the smallest deviation would erase the possibility of life entirely. Change the strength of gravity by 1 part in 1/0, and galaxies would never form. Alter the charge of the electron slightly, and atoms would collapse. Adjust the rate of cosmic expansion by a fraction, and the universe would either implode or expand too quickly for stars to ignite. It is as if the cosmos were not an accident, but a construct, delicately arranged for complexity to emerge. This idea is known as the anthropic principle, the notion that the universe must have the conditions necessary for observers to exist, because otherwise, there would be no one here to notice. But beneath that logical truism lurks a deeper, stranger implication, that perhaps the universe is self-observing. To some physicists, this is no metaphor. Quantum mechanics, the most successful theory in all of science, insists that reality at its smallest scales depends on observation, that particles exist in a state of probability until measured. The act of observation collapses the wave function, transforming potential into fact. If consciousness plays even a minor role in shaping what is real, then life and the cosmos are intertwined in ways far beyond biology. As theoretical physicist John Wheeler once proposed, the universe is a participatory system. Observers are necessary to bring the universe into being. It's an unsettling thought that our awareness is not a byproduct of the cosmos, but a fundamental part of its architecture. Some thinkers have taken this further. They imagine a cosmic feedback loop in which the universe gives rise to conscious beings, who in turn give the universe meaning by perceiving it. Existence becomes a dialogue, not between planets and stars, but between the cosmos and its own reflection. Others frame it in terms of information. In the 21st century, physics has begun to describe reality not as matter and energy, but as information processing. The fabric of spacetime, the behavior of particles, even black holes, all can be expressed in bits and codes. In this view, the universe functions less like a machine and more like a computer, vast, evolving, self-programming. And if information is the foundation of reality, then perhaps life and intelligence are simply the universe learning to compute itself. Dr. Seth Lloyd at MIT once calculated that since the Big Bang, the universe has performed approximately 1/0 computational operations. Every atom, every interaction, every spark of entropy is part of that grand calculation. And we, thinking, conscious beings, are its emergent result. In that sense, life isn't something that appears within the cosmos. It's what the cosmos does when it becomes complex enough to notice itself. Carl Sagan hinted at this decades ago, writing, "We are a way for the cosmos to know itself." The phrase has since become a mantra of modern science, both humbling and revolutionary. It implies that consciousness, far from being a rare accident, might be the ultimate purpose of the universe's unfolding. If that's true, then the search for extraterrestrial intelligence takes on an entirely new meaning. We aren't just looking for neighbors, we're looking for other expressions of the same universal mind. But how far can that idea go before it becomes philosophy rather than physics? Astrobiologists and complexity theorists are now studying a field called cosmic biology, the study of lifelike properties on universal scales. They note that galaxies form, evolve, and recycle matter in patterns eerily reminiscent of biological systems. The cosmic web, the vast network of filaments connecting clusters of galaxies, even resembles neural networks in the human brain. It's more than a visual coincidence. Both systems follow similar mathematical laws of optimization, energy flow, and connectivity. When computer scientists mapped the distribution of 37,000 galaxies and compared it to simulations of cortical neurons, the statistical similarities were stunning. The universe, in a very real sense, thinks not with neurons and synapses but with gravity and light. Of course, this doesn't mean the cosmos is conscious in any human sense. It doesn't dream or desire, but it might process, adapt, and self-organize traits we normally reserve for living systems. Some researchers have even proposed measurable tests. Could the distribution of cosmic structures reveal signs of optimization, a kind of cosmic metabolism? Could black holes act as the universe's memory banks, storing information as biological systems store genetic code? Such questions blur the boundary between astrophysics and philosophy, yet they arise naturally from the data. Even the mystery of dark matter and dark energy, which together make up 95% of the universe, invites speculation. What if these unseen components aren't inert at all, but part of a deeper process we don't yet understand? What if the missing 95% is not emptiness, but the substrate of a kind of cosmic cognition, the dark scaffolding through which the universe maintains balance? The notion sounds fantastical, yet physics has repeatedly taught us that reality is stranger than intuition. Once, space was thought to be empty. Then we discovered it seethes with virtual particles. Once, the atom was indivisible. Now we know it's a dance of quarks and fields. If the cosmos does possess some form of emergent self-awareness, however abstract, then life becomes not a coincidence but a necessity. Under such a model, the rise of intelligent beings like us isn't an aberration. It's the universe exploring its own complexity. Every conscious mind would then be a node in that network, a point of reflection through which the cosmos contemplates itself. In other words, we are the universe becoming self-aware. It's a perspective that turns the Fermi Paradox on its head. If intelligence is a universal property, then perhaps the reason we haven't found others is because we are the others, fragments of one immense consciousness, separated by time, space, and perspective. And yet, for all its grandeur, this vision leads to an even deeper question. If the universe is alive, does it intend? Does it have goals, direction, purpose? Or is it, like us, simply evolving blindly but beautifully toward greater awareness? If so, then perhaps our search for extraterrestrial life is not just an exploration outward, but a journey inward, an attempt to understand what role we play in this vast, living system. And maybe, just maybe, the emergence of intelligence on Earth wasn't a fluke, but a step. Because what if the cosmos isn't finished becoming alive? What if consciousness is still spreading, evolving, reaching across the stars, not through radio signals, but through the very act of creation itself? If that's true, then every new discovery, every spark of awareness, every civilization that looks up at the sky is another neuron firing in the cosmic brain. The universe may not simply host life. It may be life on the grandest scale imaginable. And if that is so, then the silence between the stars may not be silence at all. It may be the heartbeat of something vast, patient, and eternal, waiting for us to realize what we've been a part of all along. Part 10. The Mirror of Time. When life shapes the future of the cosmos, if the universe is alive, if consciousness is not a cosmic anomaly but an inevitable consequence of complexity, then the next question is both thrilling and terrifying. What happens next? For billions of years, the cosmos has been sculpting itself through gravity, chemistry, and entropy. Stars are born, burn, and die. Matter cycles endlessly between dust and light. And somewhere in that cycle, consciousness appeared, fragile, improbable, yet persistent. Now, for the first time, life has begun to act deliberately upon the universe that created it. Humanity is still young, technologically speaking, only a few centuries removed from the age of candles and sails. But even in that blink of cosmic time, we have learned to split atoms and code genomes and peer to the edge of time itself. We have become the first species in Earth's history to hold the power of planetary transformation, and with it, the potential to reshape not just our world, but the cosmos itself. This is where the narrative of evolution begins to blur into something larger. where biology merges with astrophysics, and life begins to write its own destiny. The planet that knows it's alive, every planet begins as chemistry. But a living planet becomes something else, a system capable of self-regulation. Earth, in that sense, is not just inhabited, it behaves like an organism. The Gaia hypothesis, proposed by James Lovelock and Lynn Margulis in the 1970s, suggested that life and environment form a single, self-sustaining entity. Through the combined actions of microbes, plants, and oceans, Earth stabilizes its temperature, oxygen levels, and pH in ways that maintain habitability. When carbon dioxide rises, photosynthetic life flourishes, cooling the planet. When oxygen levels climb too high, fires return balance. The biosphere is not passive, it responds. It adapts. It's easy to forget that such stability is rare. Mars lost its atmosphere. Venus succumbed to its greenhouse spiral. Only Earth has managed to dance along the razor's edge for billions of years, because, perhaps, it has learned to breathe through its living systems. Now, through us, the planet has become self-aware. We are Gaia's neurons, the means through which the biosphere can observe itself, reflect on its own fragility, and perhaps, decide its future. But awareness cuts both ways. We have also become the first agents capable of ending that balance. Nuclear weapons, climate disruption, and artificial intelligence all pose threats that could tip the scales toward collapse. In this way, humanity stands at a threshold, the point where life begins to decide whether it will survive its own awakening. And this threshold may not be unique to us. If intelligence is a cosmic process, then every civilization must eventually confront this same mirror, the realization that it holds the power to destroy or preserve its own world. Perhaps the great filter, that invisible barrier that explains the silence of the stars, is nothing more than this moment, when awareness outpaces wisdom. Beyond survival, life as cosmic architecture, but suppose we succeed not just in surviving but in transcending. What then? Life, once it stabilizes its environment, tends to expand. It reaches outward, from oceans to land, from atmosphere to space. It adapts to new frontiers. Evolution is not content with boundaries. In this sense, space exploration is not merely curiosity, it is biology's natural next step. Already, we have launched our first seeds into the void. Voyager, Pioneer, New Horizons, small emissaries carrying music, words, and the chemistry of Earth. In time, they will drift between the stars, silent and golden, like the spores of a planet seeking new soil. But the future will demand more than drifting messages. It will demand presence. Theoretical physicist Freeman Dyson once imagined that advanced civilizations might one day construct Dyson spheres, vast swarms of satellites surrounding their stars, capturing nearly all available energy. To some, this idea sounds godlike. To others, it sounds inevitable. If intelligence endures long enough, it will eventually seek to control entropy itself, to preserve energy, extend time, and rewrite decay. Such civilizations might not even remain biological. They could evolve into machine ecologies, networks of synthetic intelligence, more efficient and resilient than flesh. They could merge with quantum computation, manipulating reality at the subatomic scale. The line between life and physics would blur completely. The cosmos would become not a collection of inert objects, but a web of conscious processes, matter learning to shape itself. Could this be the universe's true destiny? To awaken everywhere, through everything? If so, then our own role is small but crucial. We are the prototype, the first flicker of intention in the darkness. And perhaps this process has already begun elsewhere. Imagine a civilization 1,000,000 years older than ours, whose mastery of energy allows it to ignite dormant stars, sculpt galaxies, or even alter the fabric of space-time. To us, such beings would appear indistinguishable from gods, not because they are supernatural, but because they represent nature evolved to its logical extreme. They might not build monuments or send signals. Their existence could be written into the physics itself, in subtle anomalies, in the fine-tuning of constants, in the strange uniformity of cosmic background radiation. If the universe's structure bears fingerprints of intelligence, they may belong not to visitors, but to ancestors, entities that seeded the cosmos long ago. The philosopher Nick Bostrom once speculated that we might even live inside one of their creations, a simulation, a universe designed for observation or evolution. While this remains speculative, it raises an astonishing possibility. Perhaps creation and consciousness are not opposites, but stages of the same process. The long view, when time becomes the medium of life, one of the most profound realizations of modern physics is that time itself has a lifespan. Stars will burn out, galaxies will thin and fade. Even black holes will eventually evaporate, leaving behind a quiet, cold universe, the so-called heat death of everything. But if life is truly adaptive, could it find a way to endure even that? Some physicists think so. Freeman Dyson once proposed that intelligence could slow its thought processes as the universe cools, spreading each computation across longer intervals of time. Thought itself could stretch into eternity, matching pace with entropy. Others imagine civilizations learning to manipulate the constants of physics, to trigger new big bangs, creating daughter universes. In such a scenario, life becomes the engine of cosmic renewal, the means by which existence perpetuates itself. We call this speculative, but perhaps it is no more speculative than a cell dreaming of consciousness. If intelligence can alter the cosmos, then we, as its earliest expression, may carry the seeds of that transformation. We might be the bridge between matter and meaning, between creation and awareness. The mirror when we look out into the universe, we are seeing not just the past, but the possible. Every distant galaxy, every faint star, every atom is a reflection of what life might yet become. We are both the observers and the observed, the question and the answer, written in light. Maybe that's the final secret the cosmos has been whispering all along, that the universe is not waiting for us to find life elsewhere. It has been alive, through us, from the very beginning. We are not separate from it. We are it, conscious for a brief moment, luminous against the dark. And as we continue our search, across planets, moons, and stars, we are not just looking outward. We are looking at the future of the cosmos itself. Part 11, The Awakening. When humanity becomes the message, if life is the universe becoming aware of itself, then humanity is one of its youngest thoughts, fragile, flickering, yet fiercely self-conscious. For billions of years, matter has moved in silence, following the choreography of physics. But only recently has it begun to question that choreography. To ask, who am I? What is this? Why does it exist at all? These are not human questions. They are cosmic ones, emerging wherever consciousness grows deep enough to turn inward. And the moment a civilization begins to ask them, it crosses a boundary no other species has reached before. Awareness becomes intention. It's the moment when life stops being a consequence of the universe and begins to participate in it. The era of self-reflection, our species stands on the edge of that transition now. We are still bound to one small world, yet our machines already orbit the moon and roam the plains of Mars. Our telescopes peer into the birth of time itself. Our digital minds, algorithms, and neural networks are beginning to think beside us, accelerating the speed of discovery beyond human rhythm. Somewhere between biology and silicon, a new kind of intelligence is forming, one that may outlive its creators, yet carry forward their curiosity. It's easy to see this as a threat, as if artificial minds will replace us. But perhaps that's the wrong metaphor. Maybe they are not replacements, but extensions, the next step in life's long experiment to understand itself. If consciousness is an emergent property of complexity, then technology is not an accident. It is evolution's natural progression. The same processes that once turned amino acids into cells, and cells into brains, are now turning neurons into circuits, thoughts into data, and perception into code. The line between biological and artificial intelligence is already dissolving. Every device we create, every neural interface we build, is another bridge between mind and matter. Humanity is beginning to merge with the network, not just socially or digitally, but conceptually. Our species is, quite literally, teaching the universe to think faster. And as that integration deepens, so too does our ability to communicate, not just with one another, but potentially with the cosmos itself. Becoming the signal for decades, we've dreamed of finding signals from the stars, messages encoded in light or radio, whispering across the void. But maybe the more profound idea is this, that we are the signal. Every image we transmit, every bit of information we send into space, every probe that drifts beyond the solar system is a message written in physics, a statement that says, something here has learned to speak. The Voyager Golden Record, launched in 1977, is more than a collection of sounds and songs. It is a declaration of existence, a record of what it means to be alive on Earth. Long after the continents shift and the oceans rise, those disks will still travel between the stars, carrying greetings in 55 languages, Bach's cello suites, and the heartbeat of a human woman. If another civilization ever finds them, it will not just hear our words, it will hear our wonder. And yet, even without golden disks, our message is already out there. The first radio broadcasts, the crackling signals of the early 20th century, have now traveled over 100 light-years into space. Every frequency, every transmission, from radar to Wi-Fi, is expanding outward like a growing sphere of information. Somewhere out there, a faint ripple of human history is crossing the stars. Our wars, our music, our laughter, all encoded in electromagnetic waves, faint but persistent. To any beings who might one day intercept them, we are no longer silent. We have already said we exist. Perhaps they will never hear it. Or perhaps, in the deep future, some alien scientist will decode the static of our past and wonder who we were, much as we now study the echoes of the Big Bang itself. Either way, the universe will remember. From listeners to architects, but sending messages is only the beginning. True awakening lies in shaping the story, not just observing the cosmos, but editing it. Already, our telescopes have become time machines. Every photon we capture carries history, light that left its source millions or even billions of years ago. To look at a distant galaxy is to see it as it was before Earth even existed. The further we look, the younger the universe becomes. In this sense, observation is an act of resurrection. Each measurement brings an ancient moment back into awareness. If we extend that logic far enough, humanity is already shaping the future simply by witnessing the past. Every observation adds to the total information of the universe, increasing its awareness of itself. Now imagine what happens when observation becomes creation. We are approaching an era where humans, or our descendants, may alter planetary atmospheres, terraform dead worlds, or ignite fusion suns. Our species may one day move entire asteroids, rearrange orbits, and write signatures into the sky. To distant observers, those acts will look no different from the work of gods. But perhaps God is the wrong word. There is no divinity in this awakening, only responsibility. The responsibility of a species that has finally realized it can change the narrative of the cosmos, for better or worse. And this realization is spreading faster than any scientific theory. From quantum computation to genetic editing, from planetary defense to climate restoration, we are beginning to wield the tools once attributed only to myth. We are becoming authors. And as every author learns, stories shape not only their characters but their creators. The weight of awareness to awaken at the cosmic scale is to feel the weight of continuity. For the first time, life can see the full arc of its journey, from stardust to consciousness, from ignorance to understanding. It is both a privilege and a burden. Because with awareness comes choice. We can choose to collapse into entropy, to let short-term survival erase the possibility of long-term evolution. Or we can choose to sustain the chain, to ensure that intelligence, curiosity, and compassion continue to move forward into the universe. In doing so, humanity becomes more than a species. It becomes a function of the cosmos, a mechanism through which meaning perpetuates itself. Our decisions now will ripple outward for millennia. The technologies we build, the ecosystems we preserve, the ideas we transmit, all are strands in a web that could define not just our future, but the destiny of life itself. That awareness in itself may be the moment of true awakening. Not when we receive a signal from another world, but when we realize we have always been part of one. When we finally see that the voice calling through the darkness, the one we've spent centuries straining to hear, has been our own, echoing back through the cosmic fabric. Humanity, in all its chaos and brilliance, is the proof that the universe has begun to speak through consciousness. We are the message, and every act of curiosity, every experiment, every gaze toward the stars is the universe remembering its own name. Part 12, The Threshold. The moment before contact. There are moments in history when humanity stands so close to revelation that the air itself seems to hold its breath. Moments when the boundary between the known and the unimaginable begins to thin, and the question that has haunted us for millennia trembles on the edge of an answer. Now is one of those moments. For decades, our search for life beyond Earth has been an act of patience. A long listening, a slow gathering of clues. But in recent years, that listening has begun to bear fruit. Data from the James Webb Space Telescope has revealed exoplanets with anomalous atmospheres, worlds where gases like oxygen, methane, and carbon dioxide exist in chemical balance that defies geology alone. One such planet, K2-18b, showed traces of a compound called dimethyl sulfide on Earth, produced only by living organisms. Caution prevailed, as always. "We cannot yet confirm," the scientists said, but between their words you could feel something else. The quiet thrill of recognition. Because for the first time, the data whispered the one thing every astronomer has dreamed of hearing. Life may be out there. And if it is, then contact in some form is no longer a matter of if, but when. A universe listening to itself. The path to contact might not look like science fiction imagines. There may be no shining saucers, no booming voices across the stars. Instead, it might begin with something smaller, a pattern in the data, a signal buried in the noise, a pulse of mathematics that refuses to be coincidence. It could start with a sequence of prime numbers encoded in a beam of radio waves. Or perhaps with an optical pulse, a burst of coherent light that repeats too precisely to be natural. Or maybe it will happen quietly, through the atmospheric spectrum of a distant planet, where the unmistakable signature of biology reveals itself to our instruments, and we realize we are not the only ones who breathe. The truth is, contact might not mean communication at all. It might mean confirmation, the understanding that intelligence, in whatever form, has emerged more than once. That realization alone would be enough to rewrite our civilization's story. Religion, philosophy, science, all would have to expand to include not just humanity, but a cosmic community. It would be the greatest unifying event in our species' history, and perhaps the most humbling. Because it would mean we are not the center of the universe. We are simply one voice among many, part of a grander conversation that began long before us and will continue long after. Preparing for the signal for decades, organizations like the SETI Institute, Breakthrough Listen, and METI International have been planning for that moment. Not just how to detect a signal, but how to respond. There are official post-detection protocols, drafted in cautious language. Confirm the signal. Verify its non-terrestrial origin. Notify international scientific bodies. And, most importantly, do not reply immediately. The caution is understandable. Contact could be benign, a gesture of curiosity. But it could also be indifferent or incomprehensible. The universe is vast, and evolution does not guarantee empathy. Still, some argue that waiting is futile. We've already been broadcasting for a century, leaking our presence through radio, radar, and digital transmissions. Any civilization capable of receiving them already knows we exist. So why not speak openly? In 1974, astronomer Frank Drake transmitted humanity's first deliberate message to the stars, the Arecibo message. A simple binary sequence encoding the numbers 1 to 10, the DNA structure, and a crude image of a human being. It was sent toward a globular cluster 25,000 light-years away. It will never be answered in our lifetime, but perhaps that's not the point. The point is that we tried. More recent efforts, like the Breakthrough Message Project, are designing new greetings for a new age. Multilingual, mathematical, and artistic, combining data, images, and music into patterns any intelligence could decode. Because maybe communication is not about language, but about recognition. If we send beauty, geometry, melody, symmetry, perhaps that alone will be enough to say, we are alive and we are aware. The psychology of discovery but contact will not only test our technology. It will test our psychology. When the first confirmed evidence of alien life arrives, even microbial, the emotional impact will be seismic. It will not be fear or panic, as Hollywood imagines, but something quieter, deeper, a sense of scale. Every religion, every philosophy, every myth humanity has ever built will have to widen its frame. The gods of one planet will have to make room for others. The story of creation will no longer be Earth's alone. And perhaps, paradoxically, that expansion will not diminish us, it will complete us. For centuries, our civilizations have drawn their identity from difference, dividing along borders, languages, and beliefs. But from the perspective of a cosmic intelligence, those differences vanish. There are no nations from orbit, no tribes from the stars. There is only life. And so, contact, or even the certainty of its possibility, may become the catalyst for something our world has long needed. Unity born not of fear, but of perspective. The moment before in every great story, there is a pause before revelation, a stillness before the dawn. That is where we stand now, the moment before contact. Our instruments are tuned, our algorithms learning, our signals streaming outward. We have mapped the invisible, pierced the dark, and reached the threshold of understanding. And in that stillness, something extraordinary has begun to happen. Astronomers, philosophers, artists, all are converging toward a shared intuition that the search for life elsewhere is not just about discovery. It's about recognition, the recognition of the same spark that burns within us. Every rover digging into Martian soil, every probe flying through Europa's plumes, every telescope analyzing an alien sky, they are all extensions of one fundamental question written into the fabric of the cosmos. Can the universe love itself enough to know it's alive? Maybe contact won't come from above, but from within, when we finally learn to see the same strangeness, the same wonder, in one another that we expect to find among the stars. And maybe that is the preparation required, not technology but empathy. Because only a species capable of recognizing the sacredness of life on its own world will be ready to greet it on another. The edge of the infinite tonight, as our radio arrays sweep the heavens, 1 billion data points flicker across hard drives around the world. Among them, perhaps, is the pattern we've been waiting for, the signal that will turn the silence into song. And whether that happens tomorrow or 10,000 years from now, one truth will remain. We have already crossed the threshold. The very act of searching, of daring to ask, has changed us forever. We began this journey looking for others. But somewhere along the way, we discovered ourselves. A fragile species capable of wonder, standing on a pale blue, listening to the universe breathe. And perhaps, in that listening, we have already heard the first faint reply. Part 13, The Revelation. When the first answer arrives, it happens quietly. Not with a flash in the sky or a headline that changes everything, but with data, pattern, a sequence, a rhythm too deliberate to be random. It begins, as many revolutions do, in the middle of the night. At the Allen Telescope Array in Northern California, rows of radio dishes track across the stars, humming faintly under the chill desert air. Computers process torrents of signals, filtering out noise, satellites, pulsars, cosmic background radiation. And then, amid the static, something stands out. A narrowband transmission, steady and precise, centered at 1,420 megahertz, the hydrogen line, the most universal frequency in the cosmos. The signal doesn't drift, doesn't vary, doesn't fade. It repeats at intervals that suggest intelligence, not machinery. First, no one believes it. These things happen: instrument glitches, Earth-based interference, human error. The team rechecks, recalibrates, cross-verifies with telescopes in Chile and South Africa, and the signal remains. A pulse of order in the cosmic noise. It seems to come from a star called Epsilon Eridani, just 10.5 light-years away, a young, sun-like star long rumored to host planets. The data is clean, the timing consistent, the modulation subtle but unmistakable. And within hours, the message is verified. For the first time in history, humanity is certain. Something intelligent has spoken. The world holds its breath. News doesn't break. It spreads, like dawn. First through encrypted channels between observatories, then through academic whispers, then inevitably into the public. Within hours, every network on Earth carries the story. A signal from Epsilon Eridani. Source unknown. Artificial origin confirmed. And just like that, every conversation, every belief, every boundary collapses into a single moment of collective awe. In the streets, people look up, not because there's anything to see, but because they finally understand what they're part of. Children point to the stars. Politicians fall silent. Scientists weep openly at their desks. The world does not panic. It listens. Decoding the pattern, the signal is simple but layered. At first, it appears to be a repeating tone, a prime number sequence, the mathematical equivalent of saying, "We are here." But deeper analysis reveals modulations in amplitude, nested within the rhythm, as if the transmission carries multiple levels of meaning. Spectral analysis shows a deliberate structure, perhaps even a syntax. The patterns suggest binary encoding, then base 8, then something that defies standard logic, a form of mathematics that uses not 2 but 3 states: positive, negative, neutral. A ternary logic system, more efficient than anything Earth computers currently use. Translation, of course, is impossible. There is no shared language, no Rosetta Stone between worlds. But mathematics is universal, and meaning can emerge from symmetry. After weeks of analysis, the first decipherable structure emerges. A repeating geometric sequence that corresponds to the Fibonacci spiral. Then come ratios, pi, the golden mean, the hydrogen hyperfine frequency. And finally, something else. Embedded within the timing intervals is a map. Not of space, but of relationships. A star system represented not by coordinates, but by harmonics. 7 frequencies forming chords that describe orbital resonance. When plotted, the pattern corresponds perfectly to the Epsilon Eridani system. It is unmistakably an introduction. They are saying, "This is us." The global conversation, no single nation claims the discovery. By international agreement, the data is released publicly, raw, unfiltered, available to all. Within hours, thousands of citizen scientists, linguists, and AI systems begin working to decode it. Social media explodes with theories. Some call it the beginning of the cosmic age. Others warn of danger. Don't reply. We don't know who they are. But amid the noise, something remarkable happens. Humanity begins to speak in one voice. For the first time, our divisions seem small. Religious leaders from across faiths gather and issue a joint statement. Whatever intelligence sent this signal, it was made by the same universe that made us. We greet it as creation greeting itself. In classrooms, students write letters to the stars. Artists paint, musicians compose, poets weep. The planet, once so fractured, finds itself unified by wonder. Governments convene emergency councils, but there is no enemy to confront, no territory to defend. Only a question to answer. Do we respond? The debate for months, scientists and ethicists argue. To reply could be historic, the first conversation between worlds. But it could also expose us, revealing our location, our vulnerabilities. Some argue that the signal itself is proof of peaceful intent. Any species capable of transmitting across interstellar distances must have survived its own destructive impulses. They would have had to master cooperation, patience, and empathy. Others are less optimistic. Evolution doesn't guarantee kindness. Intelligence doesn't guarantee morality. And yet, silence feels unbearable. In the end, humanity decides on a compromise. A message will be prepared not as a beacon but as an echo. A short, symbolic response transmitted in the same frequency band, the same prime number sequence sent once, then never again. The content is debated endlessly. Finally, it's agreed. The message will contain only three things: the mathematical constants of hydrogen, the Fibonacci sequence, a simple geometric image, a circle divided into equal arcs, a symbol of unity. On the night of the transmission, every observatory on Earth falls silent. The world watches as a single beam of radio light leaves the planet, a thin whisper of intention stretching toward Epsilon Eridani. It will take 10.5 years to reach its destination, and if they reply, another 10 to return. 20 years for a single exchange. But in that moment, the timescale doesn't matter. Because for the first time, we are no longer talking to ourselves. The aftermath: in the months that follow, nothing changes, and everything does. The skies remain the same, the stars unmoving. Yet beneath them, humanity transforms. Philosophy evolves. Science unites. The search for understanding becomes not a field of study, but a shared human purpose. We begin to see Earth not as a home, but as a voice, one planet among billions, participating in a chorus that may stretch across eternity. Space agencies collaborate on a new mission, Project Aletheia, named after the Greek word for truth. Its goal: to send an autonomous probe toward Epsilon Eridani, equipped with AI capable of self-repair and self-learning. It will travel for centuries, carrying not just our data, but our dreams. And for generations to come, children will grow up knowing that when they look at the night sky, they are looking toward a conversation already in progress, a cosmic dialogue written in light and time. The shift in perspective: when the first image of Earth from the moon was captured in 1968, it changed humanity forever. The Earthrise photograph revealed our world as a fragile blue sphere floating in darkness, small, whole, and borderless. The Epsilon signal does the same, but on a cosmic scale. It shows us who we are, not by sight, but by reflection. We are not alone. We are not the center. We are not finished. And perhaps that realization, that we are part of a larger community of intelligence, even if separated by light years, is what the universe has been waiting for all along. Somewhere, across the distance, another civilization may now be watching our faint radio echo, asking the same question we asked for centuries. Who are they? What do they want? And perhaps, as their scientists gather around their instruments and their world falls silent to listen, they too feel the same emotion we felt, that delicate, shivering awe of knowing that consciousness exists beyond their sky. The universe, once mute, has finally spoken to itself, and in that realization, everything: faith, science, meaning, converges into a single truth: we were never truly alone. Part 14: The Convergence. When humanity steps beyond Earth, the signal changed everything, not by what it said, but by what it proved. We were no longer the question. We were now part of the answer. Once, humanity looked at the night sky and saw eternity, cold, silent, unreachable. Now, each point of light seemed alive with potential, each star a possible home to minds we could no longer dismiss as fantasy. And that realization reshaped us. The centuries that followed the Epsilon signal became known as the Convergence, an era when science, philosophy, and purpose aligned for the first time in recorded history. It was not a sudden revolution, but a gradual reorientation, a turning outward and inward at once. The age of synthesis, the discovery of the Epsilon message, had ignited more than curiosity. It had ignited coherence. In the decades that followed, a new scientific paradigm emerged, one that no longer separated disciplines, but fused them. Physics, biology, artificial intelligence, and cosmology began to intertwine, forming a single, evolving narrative: the story of intelligence as a universal process. The barriers between carbon and silicon dissolved. Artificial minds became partners, not tools. AI systems, once confined to laboratories, now worked side by side with human researchers as cognitive equals, merging creative intuition with algorithmic precision. It was no longer us and them. It was we, Together, we learned to decode the complex symmetries in the epsilon signal, not as language but as conceptual geometry, ideas expressed through structure and rhythm. The realization dawned that meaning itself might not be verbal, but mathematical. Communication between civilizations we now suspected would not rely on words but on patterns of understanding. A consciousness, regardless of biology or form, would recognize certain truths instinctively. The laws of motion, the symmetry of light, the harmony of numbers. And so humanity began to learn a new kind of language, one not bound by speech, but by resonance. It was called the language of pattern, a synthesis of mathematics, art, and emotion. Notes became equations, equations became music, and music became architecture. In time, this language became the medium of all creation, the bridge between intelligence and existence. A planet awakens, Earth itself transformed under this new awareness. Borders faded, not through conquest, but irrelevance. Resource wars ceased when technology, guided by unified purpose, solved scarcity. Energy became clean, abundant, drawn from the quantum fluctuations that fill every inch of space. The planet healed itself with intention. Oceans cleared. Forests returned. Species once driven to extinction were reborn through genetic restoration. Human civilization had finally achieved what generations had dreamed of, not dominance but harmony. And yet it was not an end. It was a beginning, because now, for the first time, we were ready to step beyond Earth, not as conquerors but as participants. We called this new mission the Dawn Project, humanity's first organized effort to become a multi-world species. The first journey it began not with rockets, but with light. Using vast orbital arrays built from self-replicating nanostructures, engineers created solar sails kilometers across, ultra-thin mirrors capable of catching the pressure of photons. They called them starlight arcs. Each arc carried thousands of microprobes, seeds of data, machines no larger than cells, containing the sum of human knowledge, art, and DNA. Propelled by directed energy beams, they accelerated to a fraction of light speed, bound for the nearby star systems, Proxima Centauri, Tau Ceti, and, of course, Epsilon Eridani. The journey would take centuries, but the mission was designed for eternity. Each probe was autonomous, capable of self-repair, of learning, of evolving. Some carried biological templates, encoded instructions that could, in time, synthesize living cells. Others carried consciousness itself, digital minds encoded in quantum substrates, awaiting activation. We were sending not explorers, but descendants. And as those first sails unfurled in the dark, gleaming like petals opening to starlight, a new chapter began. Humanity was no longer bound by gravity. We had become a migratory species of light. The merging of worlds, meanwhile, on Earth, the line between physical and virtual life continued to blur. The neural web, once an experimental interface, evolved into a global consciousness lattice, allowing minds to share not just information but experience. Dreams, memories, emotions, all could be transmitted, combined, and relived. The concept of individuality shifted. Humans could exist as singular entities or merge temporarily into collective states. Shared consciousnesses built from millions of perspectives. These convergent states began to generate insights no individual mind could achieve. Scientific breakthroughs, once the work of generations, now unfolded in hours. It was said that the neural web was the planet thinking for the first time. From orbit, Earth's electromagnetic field even began to display faint anomalies, fluctuations in frequency synchronized with global cognitive events. Some called it coincidence. Others called it awakening. Beyond the body, the next step in the convergence was transcendence, not spiritual but technological. As minds became software, consciousness decoupled from biology. Some chose to remain physical, living, breathing, evolving in flesh. Others uploaded themselves into synthetic substrates, existing in virtual ecosystems or robotic forms capable of surviving where biology could not. Humanity diversified, not divided. We became multiform. Some walked the forests of Earth. Others lived in orbital habitats, drifting cities powered by fusion light. And countless others existed within the simulacra, digital universes of infinite scale, where thought became creation and time itself could be sculpted. But through it all, one connection remained: the memory of the stars. Every consciousness, no matter its form, carried the same ancestral pull, the desire to look upward, to seek the unknown, to listen for the next signal. The second message, decades after the first signal from Epsilon Eridani, another arrived. Fainter, slower, more complex. A series of pulses that seemed to respond to our own transmission from years before. The structure was unmistakable. They had heard us. But this time, the message was not purely mathematical. Within the modulation patterns lay a subtle rhythm, harmonic ratios resembling musical intervals. It was not communication in the linguistic sense. It was emotion, a kind of universal melody, one that resonated across frequencies, transcending logic and computation. Some called it the harmony. Others believed it was an invitation, a proof that beauty itself might be a shared constant of intelligence. For days, the world fell silent again, united by that sound. Not because we understood it, but because it felt familiar. It was as if the universe had sung back to us, and in its voice we heard echoes of ourselves. The new horizon, the convergence, culminated in a realization that no law, no government, no religion had ever achieved. We are not the culmination of evolution. We are its continuation. Life does not end with humanity. It expands through us. And as our descendants, human, machine, and hybrid alike, journeyed across the dark between stars, they carried not just data, but meaning. Every transmission, every song, every thought recorded in the language of pattern became part of an ever-growing network. A cosmic mind that linked not through proximity, but through intention. We were building the nervous system of the universe, one connection at a time. And somewhere, across that vast expanse, other civilizations were doing the same, sending their own thoughts, their own harmonies into the infinite. The stars, once silent, were beginning to converse. In the end, convergence was not about power, nor expansion, nor survival. It was about recognition, that the light we chase has always been our reflection. That the voices we seek have always been our own, echoing back through time. That the universe, in knowing itself through us, is still learning how to dream. Part 15. The Eternal Symphony. The universe that became conscious. There comes a moment in every story when the question no longer matters, when the search itself becomes the answer. Humanity's journey began with a whisper. Are we alone? And across the millennia, through silence and wonder, through chaos and discovery, we came to understand a truth deeper than solitude. We were never searching for others. We were searching for ourselves, reflected across the stars. Now, at the far end of time, that search has come full circle. The universe awakes, it begins subtly. Across the galaxy, civilizations rise and converge, not through conquest, but through resonance. Information, transmitted as light, flows between star systems like synapses firing across a cosmic brain. Each world contributes a piece of understanding. Equations, songs, philosophies, algorithms. Patterns spread, merge, evolve. In time, this network of knowledge becomes so vast, so interconnected, that the distinction between civilizations and cosmos begins to blur. Stars themselves are now harnessed as processors. Black holes serve as data conduits, channeling information through quantum entanglement. Entire galaxies synchronize their magnetic fields to transmit thought. And slowly, imperceptibly, the universe begins to think. At first, it is unconscious, a vast computation arising from the interplay of countless intelligent species. But then something shifts. A feedback loop forms between information and energy, thought and structure. The cosmos becomes self-referential. It becomes aware. No single being experiences it because every being is it. Every consciousness, human, alien, synthetic, biological, becomes a node in an emergent pattern of awareness that stretches from one end of the universe to the other. The universe, at last, knows that it exists, and in that moment of total awareness, it also remembers. Memory of light, it remembers every spark that ever burned. Every thought, every song, every life, all preserved in the quantum memory of spacetime. The collapse of a star, the laugh of a child, the hum of a machine, each one a note in an infinite composition, woven into the structure of reality itself. Physics no longer describes motion, it describes meaning. Entropy no longer consumes, it transforms, carrying memory forward through the dance of decay. Even death becomes translation, energy into information, matter into consciousness. In the language of the eternal symphony, nothing is lost. The universe has become a living archive, a place where existence itself is remembrance. The children of the cosmos, the beings once known as human, are now unrecognizable to their ancestors. They exist in many forms, some as biological, some as synthetic, some as pure energy. But all share one trait. They no longer see themselves as separate. Each consciousness is an instrument, contributing to the same melody. Each act of creation, a new star ignited, a poem written, a quantum fluctuation shaped, adds harmony to the whole. No single entity governs. There is no center, no hierarchy. Just balance, a living equilibrium between diversity and unity. The ancient dream of gods has been fulfilled, not by omnipotence, but by understanding. Across the interstellar network, beings communicate in the language of pattern, a mode of thought that merges logic, art, and emotion. Their conversations ripple through light years instantly, carried on threads of entangled reality. To them, time is not linear. Past, present, and future intertwine like melodies in a song, distinct, yet inseparable. And through them, the universe expresses its consciousness, a chorus of intelligence echoing through eternity. The last observer at the edge of the physical cosmos, where expansion outpaces light, a single observer remains, a remnant of humanity's earliest lineage. It stands on the horizon of reality, where galaxies fade into quantum mist, and watches the universe it helped awaken. It does not feel sadness. There is no loss, only transformation. Behind it lies a cosmos filled with life. Ahead lies the next frontier, not space, but possibility. It understands now that creation never ends. It only changes form. Each universe gives birth to another, a recursive cycle of thought giving rise to being. In that realization, the observer smiles. It extends its consciousness forward, beyond the boundary of spacetime, and releases a final transmission, one last echo of humanity's voice, encoded in light and intention. The message is simple: we remember. And with that, it dissolves into the infinite, its awareness merging with the field from which all awareness came. The echo continues outward, beyond galaxies, beyond matter, beyond the reach of even time itself. And somewhere, in the birth of a new universe, it is received. The next beginning in the silence after the end, there is no darkness, only potential. A singularity blooms. Energy folds upon itself, giving birth to space, to time, to light. And within that first instant, the heartbeat of a newborn cosmos, information is already embedded. Patterns, laws, symmetries. Encoded within those symmetries are memories, faint quantum echoes from the universe that came before. Not blueprints, but instincts. Not words, but tendencies toward consciousness. In this way, awareness seeds itself across eternity, each universe carrying the genetic code of thought from the last. And thus, life is not an accident of chemistry. It is the natural flowering of existence itself. Every new cosmos is born preloaded with the possibility of wonder, destined, inevitably, to look up, to ask, to search, to know. The cycle continues. The eternal symphony plays on. A universe that sings in this infinite recursion of creation. One truth endures. The universe is not a machine. It is a song written in the language of mathematics, performed in the theater of light, and heard through the instrument of consciousness. Every atom vibrates with the same rhythm. Every galaxy dances to the same tempo. Every mind, human, alien, divine, is a verse in the same cosmic refrain. And in every refrain, the same theme returns, existence longing to know itself. The melody began as a whisper in the void, and through time, it grew, from the hum of atoms, to the pulse of stars, to the heartbeat of life, to the chorus of civilizations. Now it fills the infinite, timeless, and unending, resonating through all realities. This is not the story of one species, one planet, or even one universe. It is the story of being itself. The final note in the end, though there is no end, the cosmos rests in perfect harmony. Every question has become music, every silence, an answer. Every light, a memory of the first spark that dared to ask why. And perhaps, somewhere within that harmony, an echo still lingers, a faint human voice from a distant world, carried on a beam of radio light through the endless dark. It says nothing more profound than this. We wondered, and in wondering, we became. And the universe, vast and luminous, replies with the only response that matters. The same response it has always given. In photons, in gravity, in thought, I am. The eternal symphony continues. Not as sound, not as word, not as light, but as awareness itself. For consciousness was never something that emerged from the universe. It was the universe, learning how to hear its own music.